How do you find the derivative of a quotient? For example, if you want to find the derivative of e to the x divided by x squared, what is it going to be? You might think it's just going to be the derivative of the top. The derivative of e to the x is just e to the x divided by the derivative of the bottom, which is just 2x. But it's not that simple. Just like with products, it's not simply the derivative of the one times the derivative of the other. Or in this case, it's not just the derivative of the one divided by the derivative of the other. To figure out how we deal with quotients, let's think about how to do this in general. Given the derivative of f of x divided by g of x, we can write this using our limit definition of derivatives. The limit, as h goes to 0, of plug in x plus h, f of x plus h over g of x plus h, minus plug in just x, f of x all over g of x, and then divide the whole thing by h. Now, again, this maybe doesn't seem very revealing, like what does that give you? But let's begin doing some algebraic manipulation. We can combine these two fractions by putting them with a common denominator. Both will need a g of x plus h and then a g of x. So making a common denominator, we see that this first piece is lacking the g of x, so it becomes f of x plus h times that g of x. This is going to be all over the product of g of x plus h with g of x. And then the second piece is missing the g of x plus h. So it's going to be minus an f of x times a g of x plus h. And we're still dividing the whole thing by h. So let me just write that as times 1 over h. Right here on top, I'm going to subtract an f of x times g of x. And then I'm going to add back in that f of x times g of x. Notice what it lets me do now. Rearranging the terms, I can write this as limit as h goes to 0. Well, for this first piece, I see that here I have an f of x plus h times g of x minus f of x times g of x. So here I'm just going to pull out a g of x. And I'm left with an f of x plus h times an f of x. And for the second one, I have an f of x times a g of x minus an f of x times a g of x plus h. So I'm going to pull out here, I'm going to pull out a negative f of x. Pulling out negative f of x leaves me with a positive g of x plus h. But then here it would be a negative g of x, because negative g of x with negative f of x would give you positive f of x times g of x. So minus g of x. I then need to divide this all by an h. So let me divide both of these by h's. And then divide the whole thing here by my g of x plus h times my g of x. What have we achieved? Well, let's look at all these pieces. As h goes to 0, this first piece on top is just the derivative of f times a g minus f times the derivative of g all over, here I have g of x plus h, but as h goes to 0, that's just g of x, so g of x times g of x, so that's your g squared. G times g, g squared. This is how we calculate the derivative of a quotient. The derivative of f divided by g is just the derivative of f times g minus f times the derivative of g all over the g squared. Or how I'll often say it, it's you hold the bottom times the derivative of the top minus hold the top times the derivative of the bottom all over the bottom squared. Let's see this in practice now. If we want to go and calculate this derivative, we hold the bottom, so the x squared stays the same, times the derivative of the top. The derivative of that e to the x is just e to the x. Minus, we hold the top, we leave e to the x the same, times the derivative of the bottom, a 2x, all over the bottom squared, x squared squared, which just becomes x to the fourth. We can simplify this a little bit. You could pull out an e to the x if you wanted to. You'd be left here with an x squared and a 2x, but those both have x's, so we can cancel one of those x's with one of the x's on bottom, leaving you with x cubed on bottom. So you then have x minus 2 over x cubed. Okay, it seems tedious, but as long as you memorize and follow the rule every time, it'll allow you to calculate the derivative of a quotient.